Hello, Psych 1 students, and welcome to the experimental design short lecture. So basically what I'm going to do here is introduce what we call the experimental method, or how we would conduct an experiment in something like psychology. In this particular experiment, what we are doing is we are manipulating certain variables, meaning controlling access to those variables with our subjects, and then at the same time measuring a variable. In other words, we are interested if one variable is affecting another in some way. This is one of our best designs in social science. In fact, I personally call it the flagship design. Some of you may not understand what I mean by that. A flagship, using a nautical term, represents the biggest and baddest ship in the fleet. In other words, this is our bad boy, this is our go-to. It's one of our most powerful designs, and I'm going to show you why. So to understand how this works, there are two variables in play. We have what's called the independent variable. The independent variable is the variable that we are manipulating, meaning I'm going to expose some of my subjects to this variable, and other subjects will not be exposed to it. An easier way to think of this one is it's the treatment. The second variable is known as the dependent variable, or the DV. This is the variable that is being measured. In other words, it's our outcome. It's what we think will happen afterwards, or what will change after our subjects are exposed to the independent variable. So once again, essentially what we are testing is whether this independent variable causes a change in the dependent variable. So to set this up, let's imagine that we've randomly selected 100 people to participate in our experiment. Once we have 100 subjects, we would then randomly assign them to groups. In other words, I'm going to split them in half, but I'm going to do it randomly. I'm going to use probability to make up my groups, or to decide the formation of my groups. The reason we do that is to prevent bias. In other words, if I was picking and choosing my own subjects to go in my own groups, that would represent bias because it may be unfair. So if we're doing it randomly, it somewhat ensures that the groups will be somewhat equally comparative, because we are going to compare these groups. The two groups that we are going to assign them to are the experimental group, which is the group that receives the IV. In other words, they are exposed to the independent variable. And the second group is our control group, a comparison group. These are the folks that will not be exposed to the IV. So in other words, half of them would go here to the experimental group, the other half would go to the control group. So an easy way to do this random assignment stuff is to take all names, all 100 names, put each one on a piece of paper, put them in a hat, mix them up, and then draw them one at a time. So the first person would go here to the experimental group, the second person would go here, and then so on until we had 50 and 50. Now we have equal numbers of subjects in our groups, and we can run our experiment. So what we would do is we would expose the experimental group to the independent variable. Control group would not be exposed to that, and then we would measure this particular variable afterwards. So to kind of put it in perspective, I'm going to give you an example. Let's say that our subjects are pregnant women that we've randomly selected. So all of these women are around the same time of pregnancy in terms of their pregnancy, and we would randomly assign those pregnant moms to one of two groups. Once again, the experimental group and the control group. Let's imagine that we've invented this new aerobic exercise program that the pregnant moms are going to go through, and we think that our hypothesis is that it's going to change the newborn's breathing and sleeping patterns. So once those babies are born, they will be healthier in their breathing and their sleeping. So once again, we would randomly divide them. We have 50 here, 50 here. The experimental group is exposed to the independent variable. So in other words, they go through that new aerobic exercise program. It's our treatment that we're testing. Where the control group of pregnant moms do not go through the aerobic exercise program. In other words, they would do what normal pregnant moms would do during pregnancy. We then wait for their babies to be born, and now we are going to measure the dependent variable in their children. So we would look at the babies and measure their breathing and sleeping patterns for each child. We would then average both groups. So we have an average here for our experimental group, an average test scores for our control group. Then we would compare these two to see if there's any significant differences statistically. In other words, if we found that the experimental group's children were much healthier on breathing and sleeping compared to, say, the control group on average, then we can safely say that the independent variable possibly caused changes in the dependent variable. What I mean by that is the aerobic exercise program, or IV, possibly causes the newborns to be healthier in breathing and sleeping, if that was the case, and that's what we found. So this particular design is powerful because it allows us to assume cause. Now, I would want to run this study several times. In other words, replicate the findings to make sure they are consistent. But when we compare this to, say, a correlational design, this gives us much power because it's such a controlled and manipulated situation, where correlation, once again, is just too loose of a design where we're measuring two variables. So this is one of the designs we use to test treatments such as therapy techniques or possibly medication to see if medication causes changes. In other words, this design is pretty solid and it gives us some good stuff. All right, so please go on to the next lecture in the series and we will continue with research methods.